Okay, now we are done with this. We're done with deleting from head. Okay, actually, in this implementation, in the delete from head implementation, this checking for is empty is not necessary. By default, it will do nothing if the list is empty. So let's remove it. Let's delete this check and this. Okay, this is it. Okay, now let's in this video we'll implement deleting from tail of a linker list. Okay, the tail of a given linked list while deleting the tail linked list, we are required the following. Three cases. I think we have to deleting from head. The first case is deleting tail of an empty list. The second one is deleting tail of a list with only one node, and the third one is a list with more than one node. Okay, so let's delete tail. Let's name it delete tail. Okay, so similar to deleting from head, there is no need to check for the as to whether a given list is empty or not, because it will do nothing by default if the list is empty. So if the first task is if this dot head equals like this dot tail, which is if the list contain only one element, then we'll set both head and tail to null. That means that will make the list empty. So else, otherwise what we are going to do is if the list only contain one element, which is both the head and tail, and one node, if it contains only one node, we will deleting that node means deleting the tail, and that will make the list empty. Otherwise, since we are deleting a node from a single linker list, well, we got only an access. We don't have this backward access. We only got an access from head to tail. So we'll detach the tail by setting is the next of its successor to null, and the only way to do that is if we can scan until the successor of the tail starting from the head. So let's create a new node called temp, and this node will be the head. We'll initialize it to head, then for let's for this dot for temp dot next until temp dot next is not equals to this dot tail. We'll keep moving forward. Okay, once we get to the successor of the current tail, we'll set that this dot tail equals temp, and let's okay, let's first check the next of temp to null. Temp dot next will become null, and this dot tail become this temp, and this will delete a node from tail. Let's check that from our test class. Oh, I'm not writing this. Okay, let's testing delete from tail method. Okay, okay, no, we're not done yet. Let's take it down here. Okay, testing delete head tail method. Okay, like this. Hoping that I just named it like this. I don't actually remember it. Let's print the list once we okay. Okay, let's check for yeah, it's deleted, so we're correct. Okay. Okay, now let's test it. Okay, now it's deleting. The first one deleted the head, which is 9, and the second one deleted the tail, which was 7. So both methods are working as they supposed to work. So we are done. Thank you for your time. I'll come back with another method implementation, a method which can delete init from anywhere in the list. Okay, have a good time.